I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on Introduction to Organic Chemistry. So before us, a typical chemistry A-level exam question. Which row shows the correct name and classification of the halogenoalkane shown? You can look at the molecule, the halogenoalkane shown. You have to get the name of the halogenoalkane. We have three types of halogenoalkane. We have the primary halogenoalkane, secondary halogenoalkane, and the tertiary halogenoalkane. In the primary halogenoalkane, the carbon atom bonded to the halogen is bonded to 2 hydrogen atoms and 1 alkyl group. In the secondary halogenoalkane, the carbon atom bonded to the halogen is bonded to what? 1 hydrogen atom and 2 alkyl groups. While in the tertiary halogenoalkane, the carbon atom bonded to the halogen is bonded to what? 3 alkyl group and no hydrogen atom. So the first thing we need to do, we have to draw the structure of the molecule to tell whether it is a primary, secondary, or tertiary. Then we'll name the compound. So it will be, this is CH3, CH2, CH2. Then you have C. Then you have bromine. Then you have CH3. Then you have CH2. Then CH3. Now, if you look at the compound, you discover that the halogenoalkane, the carbon atom that is bonded to the halogen is bonded to what? 3 alkyl group. So it's a tertiary halogenoalkane. Number one is a tertiary what? Halogenoalkane. Then we'll have to name. You start counting from the carbon atom that is closer to the functional group, which is Br. So this is the first carbon atom, second carbon atom, third carbon atom, fourth, fifth, and what? Sixth. So it will be what? 3 bromo. You name in alphabetical that 3 bromo, then 3 methyl, hexane, because we have 6 carbon atoms on the straight chain. So 3 bromo, 3 methyl, hexane, and it's a tertiary what? Halogenoalkane. So the answer to this question is B. B is the correct answer. B is tertiary halogenoalkane, and the name is 3 bromo, 3 methyl, hexane. So it's as simple as what? A, B, C. Attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me if you encounter any difficulty. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on Introduction to Organic Chemistry. So before us, a typical A-level chemistry question that has to do with introduction to what? Organic chemistry. It has to do with bond fission. Now, bromomethane, CH3Br decomposes in the stratosphere, forming methyl free radicals and bromine free radicals, which will describe this decomposition. Now, during bond fission, we have what we call homolytic bond fission and heterolytic bond fission. In homolytic bond fission, what happens that the bond breaks and the electrons are equally what? Shared to form what we call free radicals. So this is CH3Br, CH3Br. So if undergoes homolytic bond fission, it's going to produce what? CH3 free radical plus what? Bromine what? Br what? Free radicals. So which row correctly describes this decomposition? The type of decomposition whereby free radicals are formed is what's called homolytic bond fission. It is during homolytic bond fission that free radicals are formed. Then the number of electrons in a bromine free radical. In a bromine free radical, what happens? It has what? It has equal number of, the number of proton and the number of electron are the same. So it has equal number of proton and equal number of what? Electron. So we're going to analyze the option to see which one is the correct answer. Which row correctly describes the decomposition? The type of bond is what? Homolytic bond fission. Yeah, that one is correct, which is homolytic bond fission. If you analyze A, which is homolytic bond fission, then the number of electrons in a bromine free radical is 35 because the number of proton and the number of electrons are the same. So the answer to this question is what? A. The correct answer is A. B is wrong because during heterolytic bond fission, free radicals are not formed. So B is not the correct answer. During heterolytic bond fission, ions, positive and negatively charged ions are formed, not free radicals. So B is not the answer. If you look at C, C is also wrong, despite the fact that during homolytic bond fission, free radicals are formed, but the number of electrons in a bromine free radical is not 36, it's 35 because it's a neutral atom. So C is wrong. Then if you look at D, during formation of free radicals is not heterolytic bond fission, it is homolytic bond fission. So D is wrong. For heterolytic bond fission, is positive and negatively charged ions are produced, and the number of electrons in the bromine free radical is 35 because the atom is what? Neutral. The number of protons is positive, the number of what? Electrons. So the correct, D is the wrong answer. So the correct answer to this question is what? A. So please attempt as many questions as possible. Feel free to reach out to me if you encounter any difficulty or any challenge. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me and I'll be there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. Still an introduction to organic chemistry. Before it's a typical A-level chemistry question that has to do with introduction to organic chemistry, stereoisomerism to be specific, where we talk about cis-trans isomerism and optical isomerism. Now, which compound could show both cis-trans isomerism and optical isomerism? When we talk about cis-trans isomerism, is otherwise known as what? Geometric isomerism. In cis-trans isomerism, for a compound to exhibit this type of isomerism, it must contain a carbon, double bond carbon, and each of the carbon double bond carbon must be bonded to two different atoms or group of atoms. Then we talk about optical isomerism. For an organic compound to show optical isomerism, it must contain a chiral carbon, which is a carbon atom that is bonded to 4 different atoms or group of what? Atoms. So we're going to analyze the options and we're going to see which compound could show both cis-trans isomerism and optical isomerism. Now, if you look at A, let's start with A. If you look at A, if you look at this carbon, it's bonded to two the same atom. So it cannot show cis-trans isomerism. Despite it has, even though it has a chiral carbon here, which can show optical isomerism, but it could not show what cis-trans isomerism because this carbon is bonded to two the same atoms. So A is not the answer. A is the wrong answer to this question. So A is out of it. Now let's look at B. If you look at the carbon double bond carbon, this carbon is bonded to two different atoms, bromine and what? Iodine. So they are bonded to two different atoms. This carbon is also bonded to two different atoms or group of what? Atoms. So, and it also contain what? A chiral carbon. This carbon is chiral because it's bonded to 1, 2, 3, and what? 4. 4 different atoms or group of atoms. So this particular compound can show what? Both cis-trans isomerism and optical isomerism because it contains a chiral carbon, which is a carbon that is bonded to 4 different atoms or group of atoms, and it also contains carbon double bond carbon. Each of the carbon double bond carbon is bonded to 2 different atoms of what? Or group of atoms. So it can show cis-trans isomerism and it can also show what? Optical isomerism. So the correct answer to this question is B. So B is the right answer. Now if you look at C, let's see why C is wrong. If you look at this carbon is bonded to 2 different atoms. This carbon is also bonded to 2 different atoms. It can show cis-trans isomerism, but it cannot show optical isomerism because there is no carbon that is chiral. This carbon is not chiral because it's bonded to the same bromine atom. This carbon is not chiral. It's not bonded to 4 different atoms or group of atoms. This carbon is not chiral. This carbon is not chiral. So C is wrong. C is not the answer. If you look at D, this carbon is bonded to what? To the same atom. So it could not show cis-trans isomerism. This carbon is bonded to what? 2 different atoms. And there's a chiral carbon. Even though this carbon is chiral, but it could not show what cis-trans isomerism because this carbon is bonded to 2 the same atom or group of atoms. So D is wrong. D is not the right answer. So the right answer to this question, the correct answer to this question is B. So please attempt as many questions as possible. Feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me if you encounter any challenge, any difficulty. I'll always be there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. Still on Introduction to Organic Chemistry. I'm back with my lectures. How many isomeric esters have the molecular formula C4H8O2, which is still on isomerism? So how many isomeric esters have the molecular formula C4H8O2? Now, if you look at esters, the molecular formula, general molecular formula for esters is CN, H2N plus 1, COO, CN, H2N plus 1. N is equal to what? Number of carbon atoms. Number of carbon atoms. carbon atoms. So here we have 4 carbon atoms. C4, the general formula is, the molecular formula is C4H8O2. So if we say if the number of carbon atoms here is 1, and the number of carbon atoms here is 2, that means overall we'll have 4 carbon atoms. So we'll have what? It will be CH3, COO, CH2, CH3. So this is one of the esters. So have 4 carbon atoms, 8 hydrogen atoms, yes, and 2 oxygen atoms. So if we say, let's say n is equal to 1, if we say n is equal to 2 here, and n is equal to 1 here, we're going to have CH3, CH2, COO, CH3, which is methyl propanoate. This is another isomeric ester that can be formed. This is ethyl ethanoate. Why this is what? Methyl propanoate. So if we now decide to say if n here is equal to 0, let's say n here is equal to 0, and n here is equal to 3. So we're going to have what? HCOO, then CH2, CH2, then CH3, which is what? Propyl methanoate. So this is the third one. Yeah. So these are position isomers, isomeric esters, which are position isomers of the ester with the molecular formula C4H8O2. So we can obtain 3. So let's look at it again. If we look at the third one, which is propyl methanoate, we can form a side chain with CH2 and CH2. So we'll have another one. So we can have a chain isomer, which is HCOO. Then we'll take these two to form a side chain. So you have CH, then CH3, then you have what? CH3. So this is another one, which is a chain isomer of this. 4 carbon atoms, 8 hydrogen atoms, and 2 oxygen atoms. So we'll have what? 1, 2, 3, and what? 4. So we can form 4 isomeric esters that have the molecular formula C4H8O2. So the correct answer to this question is what? C. It's as simple as what? A, B, C. Attempt as many questions as possible. Feel free to reach out to me if you encounter any difficulty, any challenge. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me and I'll be there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. Still on Introduction to Organic Chemistry. Before us is a typical examination question, A-level chemistry question on Introduction to Organic Chemistry. So the question before us, the compound aspartame is widely used as a sweetener in diet soft drinks. Aspartame is chiral. There are no chiral carbon atoms in C6H5. How many chiral carbon atoms are present in a molecule of aspartame? When we talk about a chiral carbon, it's a carbon that is bonded to 4 different atoms or group of atoms. Any molecule that contains a chiral carbon is capable of undergoing optical isomerism. It exhibits optical isomerism, where you have 2 optical isomers that are non-superimposable with mirror images of each other. So in this compound, we're going to identify what? The carbon atoms that are bonded to 4 different atoms or group of atoms, which are the chiral carbons. So let's check all the carbon atom. So this carbon atom is not chiral. This one is not chiral. This one is not chiral because it's not bonded to 4 different atoms or group of atoms. This one is not chiral, but this carbon is chiral because it's bonded to 4 different atoms. NH2 is bonded to H here, then it's bonded to this and this, 4 different atoms or group of atoms. So we'll have 1 chiral carbon. This is 1 chiral carbon. This one is not chiral. Then this carbon atom is chiral. It's bonded to what? H here. It's bonded to this, bonded to 4 different atoms or group of atoms. This carbon is not chiral. This carbon is not chiral. So the answer to this question is what? 2. So we only have 2 chiral carbon atoms, which is 1 and 2. This is the second one and this is the first one. So we only have 2 chiral carbon atoms. So how many chiral carbon atoms are present in the molecule of aspartame? In a molecule of aspartame, we have 2 chiral carbon atoms. 2 carbon atoms that are bonded to 4 different atoms or group of what? Atoms. It's as simple as what? A, B, C. attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.